It's Blockchain Bernie again here with my latest live stream. This video is about some of the internals of Solana. It's called To Anchor or Not to Anchor. So who is this video for? If you just want to learn a little bit more about Solana works, how Solana works on the inside, this video is for you. If you're thinking about writing your own little Solana app or a larger Solana app and thinking about what tool chain to use in order to write your app, this video is also for you. And if you're interested on the Bitoku chain, the future storage layer for Solana, link in the description, bitoku.io, check it out. There's a white paper there and a light paper there and everything. So, you know, for any of these target groups. And if you don't know much about crypto, it is interesting for you. I'll keep it, you know, digestible for beginners. But if you're an advanced user, you know how crypto works and stuff like that, just want to know a little bit more how Solana works and what the Anchor framework does, right? Anchor framework is supposed to make it easy to get started to build apps on the Solana chain. The backend app, right? The so-called smart contracts, which Solana doesn't call smart contracts, it just calls it programs. So that's what this video is for. If you like content like this, give this video please a thumbs up. It really helps the YouTube algorithm. I would really appreciate it. And also subscribe to my channel if you haven't already done so. All right, so let's dive into Solana programs, Solana transactions, Solana instructions, and how you could write your first app, or someone else could write an app, or we as Bitoku Labs write an app because we are writing the storage layer right now as we speak, and which is also, you know, one end of it is a Solana app and the other end is running on our own blockchain, the Bitoku chain. All right. So with Solana, you know, everything's about transactions. So you've heard about that when working with blockchain and crypto, it's all about transactions, right? You approve a transaction in your wallet, right? The wallet will sign that transaction with your private key that's stored inside the wallet, right? So that makes it all about privacy, about you control what you do, right? So never store your crypto in centralized exchanges for extended periods of time. Always store it in your own wallet and manage your own keys. You have to learn a little bit on how to keep your keys safe and stuff like that. But it's not that much to learn, and it really pays off because, you know, in the end, it's going to be called self-custody. So you take care of your own crypto, and that's what we want. So back to transactions. So when you do something, you know, the easiest, you know, the most basic transaction that everyone can understand is just a transfer, right? You can transfer SOL, which is the native currency, from one wallet to the other. You can transfer tokens, right? USDC would be a token, or a bonk, you know, Solana's own dog-themed coin is also a token. And, you know, there's so many other tokens. You can transfer tokens, right? So, but a transfer is only the simplest of all transactions, right? So if you do something more, for example, purchase a Bitoku node, right, for a specific price, that's a more complex transaction. And you can do that in Bitoku's node store. Again, if you want to know more about Bitoku, go to bitoku.io, a link in the description. So, and if you go to DeFi, if you go to platforms like Orca, where you can swap one token to the other, that's also a little bit of more complex transaction, right? And we're all talking about Web3. So there's going to be more and more apps, DApps, you know, decentralized apps that run on the blockchain, and they're all going to be based on transactions, because that's what smart contract chains consist of, transactions, right? And a transaction is just what a SQL transaction is. It is guaranteed to, you know, either the whole transaction with all the code that it contains is going to be executed, or if anything fails in that chain of code that runs inside the transaction, then the whole transaction will automatically be rolled back, right? So it's an atomic execution, right? So either if you do a transfer from A to B, you want to have the amount subtracted from A's wallet and you want to have it added to the B wallet, right? And you want this to be an atomic transaction, right? You don't want, oh, I take the money from A, but I don't credit it to wallet B, and then boom, right? Because there's an error, I can't credit it to wallet B. Then I have to roll back the first part, which is, debiting wallet A. Okay, so that's what a transaction is. And in Solana, a transaction is further subdivided into instructions, right? And that terminology is a little bit weird because, if you're like me and you've been a programmer for a long time, an instruction is something like, one command in machine language or in assembly language. That's one instruction, right? So Solana has redefined that word instruction. So I absolutely love the terminology in Solana in many, many ways, but this single choice here to call that an instruction, that might not have been the very best choice. So anyway, they call it a transaction, and that transaction is just a step in a transaction, right? So one transaction can have several instructions, and each instruction is one procedure, one function in the code of the smart contract that we're building, right? So now that was a little bit of terminology. Now terminology is done, so now you're actually writing the code. So what you are writing is instructions, right? Instructions are the building blocks that transactions are made of, right? And with these transactions, you can develop usually on Solana, those are going to be developed in a programming language called Rust. I already have a few videos about the Rust programming language and its pros and cons. So check out my YouTube channel. There's some other videos there about the Rust language. So with the Rust programming language, you can, if you write Solana code, you can either write it native Solana. That will mean you just use your Rust code and you use the API that is given by Solana and that Anatoly Yakovenko has thought out back in the day. And then write your Rust code and write your instructions, which are the building blocks of the transactions. If you want to be a little bit quicker in development, there is something called the Anchor framework, right? And the Anchor framework, it's being used by 60-70% of new projects. All the hackathon submissions, 70% use the Anchor framework. Why is that? Because it makes writing your code a little bit more approachable. And I show you a few examples here of that code, which you see here. So here's the code of some of our stuff in Bitoku, right? So we have our node store here, right? And node store, that is the program where you can buy those Bitoku nodes, so you can run a validator in the Bitoku blockchain, the storage layer for Solana that we're building. It's really cool stuff, and we have developed that node store, right? And here you can see a lot of lines in that code with that start with a hashtag and then square brackets, and it says derive accounts, right? And these lines that start in that number sign hashtag type of thing, those are macros in Rust, right? So the guy that has developed Anchor, a guy named Armani Ferrante, he has written all these macros, right? And it says derive accounts, and then you have a structure here, right? So it doesn't matter if you're like a programmer and you understand some of it, or if you're not a programmer. I mean, this is kind of easy to understand, right? It's a structure here, and it means advanced rewards, PTFND in our case. It's for platinum nodes and for founders nodes. That's why it's called PTFND. And then In Solana, we have to declare for each instruction that we're writing all the Solana accounts, right? Which is kind of the data storage on chain on Solana that works for relatively small amounts of data, but not for large random access amounts of data. That's why we're building the Bitoku chain. But for small amounts, the storage on the Solana chain is just these accounts. And then we can, and then we have another macro here to, declare all these accounts. And then once we've done that, we see that whole program here, and we need to use anchor lang. So that is the macro here that tells Rust to include the anchor language, right? And then we can write our instructions after we've declared all that. We can just write our instructions and give them a name, right? Just give them a parameter with all the accounts that are going to be handled by this one, and then we can just write our code here. So what we do now with where are we? It's all live, guys. So what we do now with our Bitoku chain, right? We switched from using the Anchor framework to native Solana. So why do we do that? And that's the title of this video, right? To anchor or not to anchor. So my take, from having all the experience, and we wrote a 5,000 line Solana DApp, our node store, all with Anchor, right? It makes it approachable. It's easier to get started, but very quick you find some limitations, right? And the limitations are actually Solana limitations. So accounts only have a specific size, but then there's a few things in Anchor that are supposed to make it easy for beginners, right? So with all the stuff that is encoded in some data structures and stuff that you're working with, they automatically serialize and deserialize them, right? So what is serialized and deserialized, right? Say you have a data structure of like 7 bytes, 8 bytes, right? 8 bytes times 8 bits, 8 bits in 1 byte, so that's 64 bits. And you can encode data in there, and you need to save space in Solana, right? Because Solana is the fastest smart contract blockchain in the world. It just is. And there's no place in Solana to be wasteful with space or with compute units or stuff like that, right? So we want to be and want to stay the fastest blockchain, even with the Bitoku storage layer, right? Because only when things are fast, then block space is going to be abundant, and then the whole thing scales, and then we can get mass adoption, right? And that's the whole point of crypto, right? Crypto is not made to be, a thing for a few thousand users, right? It will only have the real potential and the real value when we have mass adoption and when everyone's using it, just as the internet or the telephone or, so many things that have network effects, right? So it has to be fast. So we have these 8 bytes, we encode some data in there, which is binary data. It's just zeros and ones, right? And then Anchor comes and says, well, that's maybe not safe, right? Because one computer can encode the stuff this way, and then another computer can encode it in another way, right? So it bears some responsibility on the Rust programmer to make sure the stuff that is encoded in that data, it is packed, but it's also safe and it works on all types of computers. And you need to have a little bit of experience and understand what you're doing on a low level, how that data is really encoded in order to do things right. And then Anchor chose to, automatically serialize it, right? So if you have those 8 bits, and let's say it's 8, whatever, it's an array of U8s or something, right? U8 means an unsigned 8-bit integer, right? It'll, deserialize those, serialize those, right? It will make it into human readable characters, and there will be, if it's a 128, it's just 1 byte. It's one and then 7 zeros, right? And it makes it into 3 bytes: a 1, a 2, and an 8, and then a comma, and then some brackets and stuff, right? So it'll be blown up by a factor of 6 or 8 or something like that, depending on the data that you have in there, which is quite nice. It makes it easy and approachable. And if your program is small, and just do it, right? For our node store, it was actually a nightmare, right? Because there's a way around that automatic serialization and deserialization, which costs compute units, right? Which you, in the end, kind of pay with your transaction fees. And it also costs, space in those Solana accounts, and Solana accounts are limited. And Solana accounts are limited to 8 megabytes, which is a lot. But then everything is pushed onto the stacks, right? So if you pass those accounts as parameters to instructions, it's going to be pushed on the stack. And Solana has a limit of 4 kilobytes, or 8, I think it's 8 kilobytes, something around that, 8 kilobytes to push onto the stack. So 8 kilobytes is very, very small if you write any D app that is relevant in the world, right? For some small play apps, that's okay. But then you have that 8 kilobyte limit, and then, with Anchor, even if you have 1 kilobyte, and then it automatically gets serialized, and it's over 8 kilobyte, right? And it is hard to debug. And then there is something in Anchor that's called no copy, or zero copy. So we use that in the end, but it's undocumented in Anchor. So it seems like Anchor is not really made for zero copy. It does work, but it's undocumented. So you need to figure it out on your own. And, with all these waste of resources, it makes it approachable. So if you do your first demo program on Solana, start with Anchor, right? Just be prepared that very soon you have some limitations, right? And with the next app that's going to be, a high volume high volume D app, which is our Bitoku blockchain, that is linked to the Solana blockchain and constitutes a distributed decentralized storage layer for Solana. We all do it in native Solana, right? And that just means you cannot have your code like this. It'll more look like this, right? You're gonna have more source files, and you're gonna have an entry point.rs, right? And there, each and every instruction, it's not like every instruction is one Rust function as we have it in Anchor. It's like, there is one entry point, right? And then within the entry point, we have to call a processor, right? So then we have the processor .rs, right? And then with the processor, there's a switch, right? And then we check, okay, which instruction is it, right? And then we call these different functions here, right? So it's a lot of what's called boilerplate code, right? Code that always repeats and does all these switch instructions and all that stuff. So that's what native Solana looks like. But once you've written that boilerplate code, right, in the end, it's not that much, right? And it's all very well documented. So there is so much sample code out there, and there's a Solana cookbook and everything. So it's not that hard to write your code in native Solana once you start with it. And it is way more efficient, and it's not wasting space, it's not wasting compute units, right? Because you only, in one instruction or transaction, you only have a limited amount of compute units. That's how it was in Solana before they introduced the local fee markets. Now it can have more compute units, but if it's more compute units and if there's demand for your instructions, then people might have to pay up a higher transaction fee in order to get their transaction through and stuff like that. So we want to be, and especially for Bitoku, which is a library that's going to be used by so many DApp developers. We don't want to add, unnecessary load there and unnecessary compute units or unnecessary space in overhead or boilerplate or stuff like that. So that's why we decided to go native Solana, and I even tweeted about that a few months ago, and said, well, first there was Solana, and we encode in Solana, everything's encoded into compact arrays in order to save 1 byte and stuff like that, right? And then came Anchor, and they blow up every 10 bytes into hundreds of bytes by serializing it, right? And I tweeted like, man, I want to go Solana native. And guess what? Anatoly Yakovenko, the Solana founder, liked my tweet, so that was awesome, right? And that doesn't mean Anchor is a bad thing. I mean, it's a great, great invention, and it has helped us a lot. It is cool stuff. But for larger apps, serious DApps and stuff like that, I would just always prefer a native Solana. That's why we are doing native Solana for our Bitoku SDK. And I hope you liked this video. It was a little bit technical. As I promised, I hope also beginners have learned a lot from this thing. Don't forget to like this video, subscribe, and catch you next time.